All right, we are live here, and I looked a little startled. I took us live and still looked startled. We're live. Hey, I'm Eric Johnson here for Serverless Office Hours. If you've never been to Serverless Office Hours, this is where we talk about serverless. And I'm going to introduce, I didn't forget you, I'm going to introduce here Elad Ben Israel. Elad, tell them who you are, what you do.
Hey, Eric. It's awesome to be here. I'm Elad, co-founder of a company called Winglang. I also was involved with creating the CDK at AWS. So that was the project that I worked on before Winglang.
That's right.
And yeah, I'm excited to chat. I think we had a chat like a year and a half ago on some other show that you had.
We did. I was doing Sam and Friends, basically.
Oh, right.
We were talking about different infrastructure as code. And hey, we got a hello from Florida. Hey, Nathan, how's it going? If you're watching, tell us where you're watching from. We're on YouTube, we're on Twitch, we're on LinkedIn. So let us know where you are. Glad to have you. Yes, it was about a year ago, and I'd say Wing is still fairly new. In the scheme of things, but you were really new. Hey, Julian's watching us. Julian is usually the host on this. It's hard to tell, just so you know, because Julian and I are pretty much twins. Julian, all his hair is on his head. All my hair is here. That's how you tell something. And Julian has thumbs, so it's pretty much how you tell the difference between us all. So, hey, Sean, hey, we got a lot of Florida represented here. So, all right. So today, we are going to be climbing into. All right, and we had this discussion just last week. We don't necessarily call it infrastructure from code. It's not infrastructure as code. It is, and what do you call it?
You tell me.
I tricked you, didn't I? It's infrastructure plus code, I think is what you all call it. And code. Within code. Right next to code. So it's this idea of kind of this merging, and we're going to get to building. So if you're watching this going, hey, just show us the code, we're actually going to jump in literally in just a moment. And so, but this idea of when you're building serverless applications, there's it used to be, and I don't want to do the whole talk we did last week over because it really talked about this, but it used to be that you had your operational team, you had your code team, and never the two shall meet, and your operations provided your infrastructure, your code provided your code, and that's how it went. But serverless has changed that whole paradigm, right? And serverless has changed it so that you really are kind of doing infrastructure and code at the same time. So hey, there's Shai. Shai's giving us a hello. So hey, good to see you, Shai. So Elad, this was kind of the driver to create Wing, right?
Yeah.
All righty. So
Definitely.
if you want to expand on that, I don't want to tell your whole story, but kind of why
No, I love hearing you tell this story. It's much you do it much better than me. Totally.
Oh well, thanks. It's the goatee. I'm just.
But yeah, I think it's exactly. The reliance on cloud services when you're building applications, whether they're serverless or not serverless, actually, right? Like the more you lean on the cloud and you leverage managed services as part of the functionality of your application, then they're part of your application. Yep. And separating these two into like completely different programming stacks, and oftentimes like completely two organizational, areas,
right.
Creates a lot of friction. The more you lean on these cloud services, and I think this is what the cloud is about, right? Like it's about leaning on these services and leveraging their capabilities. And so I've seen building the AWS CDK. We've seen how the CDK was like a catalyst for teams to be able to leverage more and more cloud services in order to build their applications, and it was great to see that. But it also created more and more surface area between the application and the cloud, the application and the infrastructure. And I think like that's a place where we couldn't really solve it with like existing languages, because existing languages were all designed around this paradigm that everything is running inside of one computer. Mm-hmm. And that's not the reality of the cloud anymore.
It's not. I remember when you told me, you're like, Eric, because we've been talking about this for quite a while. Now, I say we've been talking about this is all Elad's idea. It's just he kind of let me in on it a while back. And so I remember when he said, we're going to create a new language. And I was like, do you remember me like, is that the right approach, though? Is it? And now I'm a believer. I really am. I feel like that because of after seeing your vision, seeing what you put together, and, you know, what's another language to me, right? I'm so good at it. So
I mean, we are definitely trying to create a language that's going to be super easy to approach and learn. Yeah. It's kind of like a dialect of JavaScript and TypeScript in many ways. And so I feel like a lot of people who come from those languages would feel right at home super quickly. And we're also creating bindings for other languages. Like we've actually had secretly released support for TypeScript, and we're starting
now.
Oh, shit.
Your secret's out.
No, it's actually in our documentation, but it's not like front and center at this point, because we still think Wing is a better experience in many ways. Yeah. But we also have customers that are saying, you know what, we really do prefer to use TypeScript as our primary language, and so we want to leverage Wing's capabilities without necessarily adopting a new language. It definitely means that in the area where this friction between infrastructure and code happens, then they have to work harder because they don't have that language support. And I think you'll see some examples soon.
Yeah. We're gonna, so today we're going to climb into and a little background on this. Since I've been using Wing, I've been like, I need workflows. I gotta have workflows. We need workflows because we spend, especially if you're one who uses, like, I'm a step functions user, right? So that's my workflow. When we're building these out, I have found, and maybe it's made me lazy, and Elad, you always talk about being a lazy developer, but it's made me lazy, and I don't want to write if-then code. I don't want to write routing logic in my code. I want to kind of abstract that away, right? And so, and I want to be able to have some type of workflow. So let's actually, are you ready for your screen to come up here?
Yeah.
Okay. I always ask that. I'm like, were you viewing your bank last? Yeah.
Doing my daughter's skiing.
Yeah, exactly. So, all right. So we're going to bring this up, and actually, there we go. Tell us what you're going to build today, and we'll kind of walk through it. And there's now, you'll be really impressed. If I were coding, it would just be a bunch of copying and pasting, because there's no way I could. Elad codes like he types just regular English. It's pretty amazing. And so
I've coded much faster than I type. Like, I think
talking, however, is hard for Elad.
I learned English through coding, not the other way around.
Okay. Oh, I like it. Okay. All righty. All right. So so tell us what you're gonna build, and then let's get into it. And you explain what you're doing.
I think maybe we'll quickly just go over the fundamentals of Wing to make sure that everybody's on the same page. And then I hacked on something that, as you said, we talked about a few times, and kind of like this baby workflow engine that I created using Wing. And so I thought it would be interesting to walk you through some of the implementation and play with it a little bit, and maybe throw in some generative AI stuff and build something together. I don't know. We'll figure it out. And so you
gotta have you can't have a live stream without at least saying generative AI and then doing generative AI. I mean, come on. So good job.
Totally.
And I'm going to say real quick, I was going to type this in, but if you have questions, Serverless Office Hours, we answer questions as well. If you want to know, I will interrupt him right mid-code and ask Elad questions, or I'll try to answer. So please hit me with your questions, and let's go.
Yeah, and I'd need you to supply ideas and thoughts to what we're building, because
okay.
I don't have any.
Yeah.
Okay, so just the fundamentals for Wing. One important thing for people to understand, and probably the only super novel aspect of Wing as a language, is this concept of pre-flight and in-flight. And the easiest way to think about it is that pre-flight compiles to your IAC configuration, which could be CloudFormation, could be Terraform, or it could be any other IAC that's supported. And in-flight compiles to code that runs on your cloud. And so Wing has these two programming phases, pre-flight and in-flight. The pre-flight phase is actually running during compilation. So when I compile my code, I actually run the pre-flight code. And another way to think about it is pre-flight is CDK. It's basically like CDK. When you run CDK synth, you basically compile your definition into CloudFormation or to Terraform. And pre-flight is the thing that runs inside your cloud. So a simple example would be if I do new cloud bucket here, then I get a bucket, the definition of a bucket. And so if I compile this, to Terraform AWS, and I look at the target here, then you'll see a Terraform file with a bucket. Okay, simple.
Hey, Elad, I'm going to interrupt you real quick because we do have a question, and Alpercode's asked this, and he said, never mind, he answered. But you didn't answer it fully because it's not just CloudFormation. So what does Wing generate to create infra CloudFormation? And I'll let you answer.
So basically the way Wing is architected, like many other compilers actually, is there's the front end and the back end of the compiler. And so the front of the compiler is Wing. That's the language. The backend is basically a pluggable architecture, and you can like bring in your own backend. And so Wing is shipped with a bunch of backends: Terraform AWS, Terraform GCP, Terraform Azure. AWS CDK is a backend for Wing, but anyone can actually create a backend. And so I can actually take Wing and we've had some people thinking about those ideas of like compiling Wing to Kubernetes, Helm charts, and to Kubernetes ACK, or to Crossplane, or compile Wing to use. And so the backend basically determines everything about how your application is deployed, which is pretty cool. Like in a way, it's kind of like this meta CDK, right? Like it's not a CDK that's particular to a specific target. It's an abstract CDK that you can define your application with one language and then compile it down to different providers. And now the most interesting provider, I think, is a cloud simulator, the Wing Cloud Simulator, which is a dedicated provider that we're building that simulates the cloud resources, and you'll see it in action super soon. So stay tuned.
Okay. So right now with that, and I've seen you've got CloudFormation, you've got Terraform, you've got CDK, you've got different versions of CDK that are already kind of come with it, right?
Yeah, and you can actually use any CDK construct when you're using Wing, but it has to be compatible with the target that you're compiling to. So you can use AWS CDK constructs and all of the L2 constructs if you're compiling to AWS CDK. You can use all of the Terraform constructs from CDKTF, and if you're compiling to Terraform. If you're compiling to Kubernetes, you can use CDK for Kubernetes constructs. And so,
nice. Okay.
Not surprising, I guess. This.
So Alpercodes, I hope that answers your question. It's like any other great computer question, the answer is, well, it depends. But in reality, is a lot of stuff. So it's not just limited to one. So lots of flexibility.
Yeah, and I think the most important part is that it's customizable, and so you could also customize your own platform, target platform, and then control everything about how your application is compiled, is deployed, which we see. This is where we see platform teams basically join forces with developers, right? Like that's basically how platform teams and developers can collaborate. Developers use Wing or the Wing framework, but use Wing to build their applications, and then platform teams can customize the platform configuration using these backends. And so that's okay. So as I told you, this is a cloud bucket, and I can. Sorry, I'm looking at the wrong screen. And so what I wanted to show you here is we actually have this little button here, which opens up the Wing Cloud Simulator. And I can see my little bucket here, and I can, if I delete this, you'll see that it's hot reloading. So like basically the developer experience that we're after is very similar to the developer experience that web developers have, right? Like they write their code and they get like instant hot reloading on their browser. And you'll see what this can do. But this is, mind you, it's running in the simulator, right? It's not running on AWS. This is, I think, one of the most provocative things that we're doing. I really think it's interesting. Okay, so we saw pre-flight. This is basically pre-flight code, and I can do things like for I equals, for I in one, whatever. Let's create 10 buckets. Bucket I. Now I have 10 buckets. And one cool thing that we can do that I don't think we had before. We can actually customize some of the some of the visual elements here, and so I can do something like this, or I can even do change the color. Let's say I want to do color orange.
No, this is new.
And the very, very, very cool thing that we've added recently is Bring UI. And Bring UI is basically a way to customize the behavior of the panel on the console. And so what I can do is I can do something like UI button, and then let's say upload file. And then what I'm doing here is basically writing some code in reaction to the button. Okay. And so now let's see, button, I need to. And so now if you look at this, oh, actually the button is not, wait. Okay, I'll show it to you later. It's actually it's pretty cool, but I don't want to waste time on this. So this is basically pre-flight. It's code that runs during compilation. It produces, if I compile this to Terraform, I'll get 10 buckets, blah, 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 blah. Let's leave one bucket because
Alper, I see your question, and we're going to hit it in a little bit. It's a good question, so I want to build a little bit, but we'll definitely answer this question, or because I feel like we could go on a while for this. I feel like we could talk a while on your question, so we're going to wait just a few minutes.
Okay, I'm intrigued now.
Yeah.
Okay, so now I've defined another resource called function, and a function is basically a serverless function. And it takes what we call an in-flight closure. So in-flight closure is like a code block, in JavaScript or in TypeScript or Java or whatever, only that it has this modifier called in-flight. And in a way, this is the unique thing about Wing, is this one tiny modifier. What it tells the compiler is it says it's kind of like async in a way, but it's async that not only runs later in time, it also runs in a different place. So it's kind of like async in 2 dimensions in a way. What it tells the compiler is that the code that's written inside this block is something that I want to be able to package and ship to the cloud. And we can actually create containers with in-flight closures as well, not just functions, right? It's basically a unit of computation that I can package up and ship over to a different machine and run it in a different machine. And so let's say I'm logging something here. And so you see I have my function here. I can invoke it. I can see the log over here. All good. So now I have like a little function. And if I compile it to AWS, it'll be a Lambda function that I can invoke, and it'll emit this log. But
can y'all see his screen, by the way? It's small to me, but I have kind of small windows. So let me know if you can't see it. So sorry to interrupt, Elad.
No worries. Now, when is this becoming really interesting? Exactly in this connection between in-flight and pre-flight, right? Like that's the surface that I talked about earlier. And so how does this connection manifested in Wing is basically being able to what we call lift objects from the pre-flight world into the in-flight world, basically lift them up to the cloud. And in this case, what I can do is I can call B. I basically can say B dot, and then I have like a bunch of APIs that I can interact with this bucket. And so in this case, let's say I can post a file, hello, Eric, blah, blah, blah. And as soon as I've done this, I can check that this is actually working. Now we see my bucket has this object with hello Eric. I can also see that the compiler has this relationship now between my function and the bucket. And if you've been building serverless applications or anything on the cloud, you'll know that this relationship that is needed, because if I want to deploy this to AWS, for example, I need this AWS Lambda function to have permissions to access this bucket. And in order to know this information, I actually need to know what's running inside the Lambda function, right? And so Wing takes advantage of the fact that it understands both the inflate and the preflate, and it can automatically create IAM permissions for you because it knows what you're doing with the infrastructure. And so this is where this line is coming from. Okay, now to the long question.
Yeah. So we got two of them here because this is a good breaking point. So we've got this question. Alper's asking, what are the benefits of learning a new language to generate CFN with more layers, et cetera, WingSync or whatever? So I'm going to take a shot at this real quick, and then of course I'm going to let you correct me. But for me, here's the benefits. Number one is what Elad just talked about. There's opinionated, settings that are happening in the background that a lot of developers struggle with. IAM is hard. There's just no two ways about it. With the Lambda function, you're dealing with what's allowed to invoke the Lambda function, and then you're also dealing with what is the Lambda function allowed to do, right? And so you kind of have to set all this, whereas when you're using something like Wing, it's happening already. The second thing, and this is the really big one, and this is the thing that I actually talk about a lot, is and for a long time, I have said, get to the cloud as fast as possible. Debug in the cloud, things like that. And that really is a cool solution. The problem is it's not as easy as it seems, right? And so what developers really want is they want this single pane of glass. They want another way of saying this is they want to build monolithic applications, but have it compile to microservice. They want to take advantage of the distributed apps, but it's hard to build in several different places, right? And at AWS, we're doing a lot to kind of bring those together as well. We agree with Elad that this disjointed way of building isn't the best way. Now, to come to your question of why a different language, I'm going to turn that back over to Elad, and he can explain that best. I would just be parroting what Elad says on this one.
Okay, I think the answer has two parts. One part is Wing as a language is interesting only because of the in-flight capability, right? And so I think like it's pretty easy to see that there's a lot going on behind the scenes here. If you have experience building stuff using serverless or containers or being able to actually interact between my in-flight code and my pre-flight code, or between my runtime code and my infrastructure, requires quite a lot of boilerplate and glue logic and knowledge of all of those layers. And by creating a new language, we're able to actually codify this into the language syntax, into the compiler, and there's actually quite a lot of heavy lifting, pun intended, heavy lifting. The lifting mechanism is actually pretty complex, and it's composable, and there's a bunch of really interesting kind of programming language aspects to this. But as I said earlier, you don't have to use a different language. You can also use the TypeScript bindings that we have for Wing, and the experience is not going to be that different. I can quickly jump over to our docs and show you. Maybe we can do a whole episode about this, but here's an example of how to create a bucket in the TypeScript version of Wing. So you basically import a Wing Cloud Framework, and then you can do new cloud bucket, root bucket. So this is kind of like a CDK programming experience. And then if you actually want to be able to write in-flight code, then you have to work a little harder, because what we've done with the compiler in Wing, we actually have to be explicit about. And so in this example, we have this basically the same example that I wrote, is like I'm creating a bucket, and then I'm creating a function. And then what I'm doing here, I'm lifting my bucket, and I'm lifting some plain data into this async function that takes them as context, and then I can interact with them from here. And this is actually reasonable, right? Like it's not the end of the world to use this, of course. And we're starting to see people use this. And so I think like we want to give people choice and meet them where they feel comfortable. Wing as a language is going to have more capabilities that are cloud oriented. And I'll show you some of those, but we do have a roadmap of really cool features like generating API specifications, right? From shapes, from structs, parsing JSON and JSON schemas are first-class citizen in Wing. And so there are a bunch of things that we're going to build into the Wing language to make it amazing for building cloud applications, but that doesn't mean you have to use it. And in order to enjoy a lot of the value that Wing as a framework has to offer. And so that's one side of this question. I think like the other part of one side of the answer. The other part of the question, which was, I think, about abstraction layers, right? Like regardless of the language, this is another abstraction layer. And I think my answer to this question, which is very common, is that we're constantly using tons of abstraction layers, right? Like the fact that we're not concerned by that in many cases is because those are well-designed layers and less leaky than some other layers. I think CDK, one of the problems that I think we had with the CDK is that it was a leaky abstraction in production. When you use CDK today, if you don't understand CloudFormation, you're basically unable to continue to production in a way, because once you deploy your application, then the deployment process is based on CloudFormation. And when you're actually running your application, then you have to understand everything about how your application is structured inside your cloud provider. And so that becomes a leak in the abstraction. You can't just say new blah, 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 and expect this to behave the same way in production. And what we're trying to do with Wing is we're actually trying to fix this, because I feel like that's one of the biggest barriers for people using the CDK to, in complex systems, is that they lose some of those mental logical models when they carry over to production. And so that's an example of a leaky abstraction. And I think what we're trying to do with Wing, we're trying to create a solid abstraction. It's hard. We're going to fuck it up in a lot of ways. But I think using an abstraction in itself is not a good reason not to use something. I think like if it's not a well-built abstraction, that's a good reason not to use something. Again, we're very early in the game, so I feel like if you pick up Wing now, it's gonna be hella leaky, and so you're gonna need to help us, right? Like I feel like that's part of where we are, and open sourcing this has been, instrumental, because we really do need to flush out all the quirks and make sure that the experience that you get is a great experience across the board.
So I'm going to just follow up. And we have another question that came in, but I'm actually going to do Alper's follow up real quick, because it's already kind of based on what you're talking about. And then, but I do want to get to the building, so we'll keep this compressed here. But he basically says that it looks like an abstraction of cloud providers with this limit users to the lowest common denominator, and that's what you're working on. I mean, that's basically what you were just talking about. So, you have anything else you want to throw in on this one?
Yeah, I think specifically about this topic of abstracting the cloud provider, the philosophy is that, and again, I'll show some examples where. So first of all, we're providing a standard library, and so everything under Bring Cloud is indeed an abstraction over cloud providers, and we believe there's a bunch of resources. We already have, I don't know, like 15 resources already. I think we're going to have like 20 or so that are fundamental, that are kind of like the fundamentals of building cloud applications and carry over across providers from a functional point of view. And that's a really important point, because as I said earlier, like you can actually plug in different providers below the abstraction, and you can completely customize how your cloud function looks like, or how your cloud bucket looks like, and which configuration it uses on AWS or in GCP or in Azure. And so it's not that you're completely limited to using all the capabilities of the cloud provider, even if you're using the standard library. And then we'll see an example of using Bedrock. And so Bedrock is not an abstraction, right? Like Bedrock is a concrete AWS service. And you can still use it from Wing. And we also have a DynamoDB library, and we also have a Cognito library. And so the fact that we have a standard library doesn't mean you're limited to only using the standard library. It means that if you want, you can create applications that have that portability aspect. And some people care about that, some people don't. So again, I think like my philosophy, I'm a pragmatist. I don't feel like we can be pure in the cloud. We have to make sure that people have a way to build the stuff that they need with the tools that they need. And so we're trying to create this framework in a way that's extensible and escape hatchable and all those things.
All right, I'm going to jump in here on this one. We had one other question. Is what does it mean? You said this earlier. What does it mean? You say code runs at a different place. When you think about asynchronous, and jump in if you think I'm wrong here, but when you think about asynchronous, what it basically means is you send the request. We acknowledge that you sent the request, but we don't actually crank on the work yet. We just say, yeah, we got the request. Thank you. Then that could go into something like SQS, EventBridge, some kind of service that kind of routes that to a different place, where we might send it over to a Lambda function to run it, or an EKS cluster, or ECS on Fargate or something like that. So in that different place and even different time, that's kind of what we're talking about. Usually asynchronous is very, very fast, but also it depends on the job. There's a lot of depends on that one. But usually it's like, everything I do is what we call event driven, where you say, I'm going to send you this task, or I'm going to create an event like an API call or a button being pushed or something. And then we'll queue that, or we'll route it with EventBridge or something like that. And then we'll process it. And so that's what that means. Elad, do you have anything you want to add to that, or are you ready to build?
Let's build something.
Let's build it. All right.
So yeah, let me show you this little thing that I worked on. It's a sketch, okay? Don't hold me up to anything here. Oh my God, Copilot is.
Yeah.
So this is basically a library for creating a workflow, and the way the API design is, as I said, is a sketch, but basically it accepts an array of tasks of steps, which is kind of like step functions in a way. And so if I show you this, I now have like this little workflow, and you see I have like a little start button here, and I have a state which is empty, and naturally if I start this, it says done, because it doesn't have any.
Because it doesn't do anything, yeah.
And so now let's add. And so basically now all we have is two types of steps for this workflow. One is called execute, and the other is called check. Execute is basically just run this code, and check is basically run this predicate. So it's basically code that returns true or false. And then there's an, if true and if false. So it's basically a branch. These are the two primitives that we have for the workflow. And so let's start by creating an execute step and say hello. And now I'm using in-flights, right? So now it says, okay, give me an in-flight closure. This is the representation of the code that I want to run. And so I'm basically doing this. Sorry. And hello. And as soon as I save this, now I have like a little, you see, I have this little node here. And if I run my workflow, it says hello, right? And it also has this context state thing, like step functions. And so if I return something from here, it becomes part of the context. And so let's say number, whatever, 1, 2, 3, 4. And if I run this now, it shows me in the log, and I can also see this state over here. So far, nice. Now, when this is deployed to AWS, it'll be deployed as a Lambda function with some infrastructure for running these Lambda functions. And one of the ideas that I'm playing with is to also support compiling this to ASL. And so you can take this workflow and you can run it through native chain of Lambda functions, or you can run it through step functions. And so it becomes like a step function state machine with the steps and the execution engine and everything. Okay, let's add another step. So now I'm going to add another step, and let's say this step takes the context as input, and then basically extracts the, let's say, get number, right, as number, and then let's say returns x plus 100. Step 2, adding 100, whatever, I don't know. Not very creative. And so you see now my workflow is basically showing this flow, right? So say hello, and then this relationship is the next step. And this one's adding 100. And so if I run this now, I should be able to see, I don't know what happened here. Oh yeah, I just had this like, let's see, 10, 110. Great. Now it looks like a toy, right? Like it looks.
I want you to know, Elad, that I just slacked the GM of Step Function. Said you need to get on Twitch right now to watch this. We've been, you know, Justin, and so yeah, so super cool.
Cool. Yeah. Okay, let's add a check. Okay, and so let's say if check. Oh, let's do this. W steps check. Check if number larger than 50. So now, basically what I'm going to do is I'm going to do context, get number as number larger than 50. And then you'll see that basically I have two branches here. And again, Copilot is like amazing, absolutely amazing. But it's a little annoying at this point. Okay, so this is, let's organize it a little bit different. Okay, so now you see I have like this check. This is the condition, right? So it takes the number from the context, checks if it's larger than 50, and if it's larger than 50, let's just do something stupid for now. Let's just make sure to see that it works. So I'm gonna do larger than 50, and if it's false, then smaller or equal to 50. Okay. And now, okay, so this is, let's see if this what happens now. This is loading. Oh, fuck. Let me see. I don't know why it's doing this. Let me restart.
Now, while he's working on this, we'll make sure y'all know that this is super alpha. So
yeah, of course.
This is the joy of live coding brand new code. So
I think I ruined something. Let's debug this. Okay, this is working. And now, basically, if these are two empty, if these two are empty, let's see if this is.
It's not liking that.
Let's see. Okay, here's what I did earlier to be smart, but I don't know if it'll work.
Let's try it.
I'll do this.
You're getting some help from the audience here.
From the history, from the world.
Yeah. You're getting some question marks missing.
Question marks missing. Where?
Yeah. Maybe in the original code. I don't know. I'm just throwing that out there. I'm just the messenger here, Elad.
Okay, let's no, this looks okay. Okay, I'm gonna do this. I'm gonna store this in a branch. Sorry. Present. Yes, I'm presenting, right?
You are? Yep.
Yeah. Yep. And then I'm going to do this. And then I'm going to try and just revert a little bit.
Oh, there we go.
Because I've been trying to be smart, of course, about something.
Yeah, dude. I've given many presentations from different Git branches.
Okay, let's see. This is okay, let's see. Nope, it's not happy about it.
Didn't like that, yeah.
It's very weird. Damn. Some bug here in the console.
Yeah, you got something weird going on. That's all right.
Okay.
Another, yeah.
Yeah, I think that we can play with Bedrock a little bit.
Let's do that. Yeah.
But I owe you a demo of this.
Oh, I'll call you. Don't you worry. Yeah, let's do Bedrock. I'd love to see the Bedrock implementation. Are you using the Winglibs?
Yeah, I'm using Winglang. So
Okay.
yeah, I wanted to show you. So here we have a bunch of dependencies in our project. And I've installed Bedrock, DynamoDB, EventBridge. As I said, like we've got a bunch of, we have this pretty interesting model for bootstrapping the Wing ecosystem called Winglibs, Winglang Winglibs. And it's basically this like monolithic repository that hosts a lot of packages that people are contributing, kind of like Homebrew, if you're familiar, like they have this model. And it's starting to get pretty interesting. There's a bunch of really cool things here. There's some support for front-end framework like React and Vite, and a bunch of AWS services like EventBridge. We've got a WebSockets library, which is pretty cool, and you can build like websites with WebSockets, and it compiles to API gateway with like REST APIs and stuff like that. And one of the libraries we have is Bedrock, and so Bedrock is actually pretty simple. It's not a complex library, and the API is pretty cute. It's like you create a model, and so you basically now have like this Claude thing, and let's try to play with it. Okay, so I'm just gonna create myself a little Cloud function, and I'm gonna open up this. Now it's gonna annoy me that this thing didn't work.
Yeah, it is.
Okay, so now let's see the API. So the API is basically Claude.invoke, and now I need like the incantation, right? For I actually have it here open, I think. So yeah, let's use Claude 2.1. So this is the model, and this would be an example prompt. So let's just take some example. Claude. Something character roleplay. Something like this, maybe? And wait, I had this thing over here. 2.1. Okay, so it basically needs prompt. Okay, I'm gonna do this. Take this example.
I love watching an actual developer in action.
Actual developer
online lint for
converting strings to JSON. Okay, So here, hello world, assistant, blah, blah, blah. This is kind of like the basic example. And now let's see, r dots. Let's just print the output. Okay, where are we? Okay, so now we see my function is interacting with the model, and working. And there we go. We got a hello.
Nice. Okay.
Should we try something a little bit more interesting? That was the examples earlier.
Now, are you able to stream with
no, not yet. We actually don't have streaming support, but let's just put this in here like this. And you know what? Let me put it in the file to try that out. From text, and I'm gonna bring fs.
Okay, so you're going to read the file in here as a full prompt, okay?
I'm just going to put it here. And it's pretty interesting to see that, I've read the file pre-flight, but I'm using it in flight. And so it's actually just like transferring the data across the boundary of the in-flight pre-flight.
How's it doing that?
It's putting it inside the bundle of the Lambda function.
Okay, alrighty.
Which is, it's static data. There's no reason to do it
of course.
away. I can put it in a bucket if I wanted, but I don't see a lot of value in it right now. Okay, let's see what's happening now.
We all wait on AIs right now.
Yeah, this was much faster earlier.
Yeah. Well, the thing to understand, and you understand this, but for folks watching, is when you use like a Chat GPT or a Claude or something, it's usually streaming. So we do a streaming invocation. And so you're getting back the very beginning of the answer right away. But what this is doing is it has to get the whole thing and then sends it down. So that's why this seems a lot slower. It's really not.
Yeah, totally. I mean,
here's a
we're
challenge.
Just making a call.
Yeah, here's a challenge for you. And you it may not be one we do here, but one thing I did in another thing I'm going to do is I actually use the WebSockets API. I call how you doing? I call Bedrock streaming. There's a you can actually
streaming
say
API.
With streaming API, and then for each chunk, I send it back to the connection.
Got it.
So you basically, it's like streaming, but it allows you to use API Gateway to do it. So it's a way to
nice. Go. Yes.
Yeah,
definitely. Okay. I actually let me try to see the workflows again. I'm like
okay.
Well,
we got this. We had some. Tatai, I'm sorry if I destroyed your name. Please forgive me.
In the example you wrote for the testing, yeah, I think that's. I did play with this stuff.
Yeah. Okay, Itai Tavor. Okay, got it. And then Shai is throwing out there too. He says, "Can you try to compile your demo with Bedrock and workflows? Maybe it will work."
Oh, this guy.
Fellow Israeli, nice.
This. No, not this one. The
original one you did a hard reset to.
This one. Let's try.
What are they going to do? Tell? We're not afraid.
No,
this is called live coding.
Okay, this one.
Yeah.
Okay. Okay, so
Shy for the win.
Shy for the win. Yeah, so this is like a workflow. Now, there are some bugs here that I need to figure out. Like this line here is kind of like this self-referencing
right
thing.
That's just the UI stuff, yeah.
But and we're using some of the UI stuff that I told you, and we're still figuring those things out. But you can actually see the workflow, right? So you see, ask Claude for a joke, check if the joke is good. somehow.
What's your criteria for that?
Then, if the joke is good, then say hooray, and then print the joke. And if the joke is not good, then ask Claude to improve the joke. So basically go back and say, this is a joke, it's not good enough, please improve it. Let's see the code for a second. So basically we have
watch through that.
Execute step, goes to Claude. Hello, Claude, please tell me a joke. Blah, blah, blah. Gets the completion. And then if the joke is good, so this is the predicate. At this point, I'm just like checking if it's larger than 10 characters. So it's not that interesting. If it's true, then log hooray. Otherwise, execute. Hello, Claude, please improve this joke for me. And then it basically uses the joke from the context and returns a response and eventually prints it.
Okay. All right.
Classic generative AI workflow. I do think that there's some, I think generative AI becomes super interesting when you're doing these agent things, right? Like when you're actually like asking the LLM to improve. And we're actually experimenting with Wing and generative AI in this direction, because Wing is unique in the sense that it has this cloud simulator. And one of the problems with like generating infrastructure, for example, through AI, is that you can't have a closed loop, right? Like you can't go off and deploy your infrastructure and figure out if the AI hallucinated some bucket in another region, right? Like, and so with Wing, you can actually simulate, and it's actually a pretty interesting area that I have some customers that are interested in this, is like actually being able to generate, using generative AI, generate stuff that's like go off and deploy it on AWS and know that it'll work because we've actually tested it in the simulator. Okay, let's, should we run this? It's not good. I lost all my confidence at this point.
Well, that's all right. I have confidence in you.
Okay, ask a Claude for a joke. So here's the joke. Why can't a bicycle stand up by itself? Because it's too tired.
That's a good one.
Yes.
That's a good.
I guess we can like use another model to check if it's
to evaluate. Yeah.
Can we try that?
Yeah. You have 7 minutes, but you type fast.
I have 7 minutes. Which model would you use?
Well, one I haven't worked with is Mistral. Or you can use one of the other Claudes. You can use the Claude V3 or Sonnet. I was telling you, the interesting thing about Sonnet is you have to change your prompt. It's a whole different prompt structure. Well, it's a little different. I guess it's not total different, but. Can I test APIs with Wing? I'm getting that question.
Okay, you know what? Let's do something more interesting. Let's add an API for this. Okay, so it's going to be triggered by an API, and the API will allow us to actually pass in some inputs, and so it's going to be the type of the joke or something like that.
Okay. So this should answer the question that came up. He's going to show you how to do an API, and can you write a test against the API?
Yeah.
That's one thing you haven't shown is the actual test. Yeah.
So what would be the API? Let's say post jokes, right? And the body is going to be looking like this, topic. Okay. And so what I've done here, I basically defined like what we call in Wing struct, which is a shape of data. And what I can do is I can basically use body dot try parse JSON request body. And then what this does, it basically uses a JSON schema that's generated behind the scenes for this struct. And it gives me a strongly typed object that I know is valid. It's not like in JavaScript when you're just slapping a type on some JSON data. It's basically verifying that data is correct and gives you access to this data. And so just another example of like the cloud native nature of Wing in that sense. Okay, so now we have a topic, and what we're going to do is we're going to basically make jokes. This is my workflow, right? So I'm going to take this API. Let's move this stuff below this stuff. And so here, I'm going to do make jokes dot start. And here I'm going to give it a context. And so I'm going to put topic, body topic. And so this basically trigger the workflow with the context that has the topic in it.
Okay.
And I guess that's it, right? Like that's basically the API. And so you see now I have like this API that's interacting with my workflow. It's like basically starting my workflow. It's interacting with it. But I also need this to be read from here, right? Get topic as string. And then please tell me a joke about topic. Okay?
Wow.
Let's see.
And there you go.
Let's see if this works. Okay, I'm going to remove this. And you see that now I have like this HTTP client that knows my API because it knows, so I have post jokes. And you'll notice if I just put something here, it's going to do 200 OK. And the reason it's going to do 200 OK is because I didn't do something here, right? Like that request, status 400. Okay, let's check this. Great. So this is bad request because it wasn't able to parse. Topic.
Drummers.
Drummers?
Yes.
Okay.
I heard that disgusting scoff sigh you made. We're going to talk about that off screen.
Okay. The reason I returned bad request is because I didn't return here 200, but it did trigger the workflow. And so, topic drummers, joke. Sure, here's a silly joke about drummers. Why do drummers have more than one brain cell? Blah, 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 blah. Joke is good. Yes, it's good. And then obviously, let's say I want to upload the joke into a bucket at the end. So now instead of doing this, or put it in a queue, right? Whatever.
Yeah, or drop it to DynamoDB or something, yeah.
Or drop it to DynamoDB, or ship it to event stream, to event bus. Okay, so I added a bucket. We've actually improved this performance of the upload. So you see now I have like my little bucket here. Let's do programming languages. 200 OK. Working, la, 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 la. Bucket. Joke.
Wow. All right. So in 2 minutes, can you write a test?
Yes. Test.
Nice.
Okay, so I'm going to bring the HTTP module because I want to issue an HTTP request. Now, I need to hit the API of the URL of my API. So I can actually do api.url and do it like this. And Wing, we didn't talk about this, but Wing can actually run these tests on the cloud as well. And so when this is running on the cloud, this is going to be the REST API of the API gateway. The URL of the API gateway will resolve everything. It's just going to work out of the box. Okay, JSON stringify. I can actually do this, which is cute. I can make this strong type. Chicken. Okay, thank you. It's like AI models working with each other. Okay, so this is basically a response, and I'm going to assert that the response is okay. And what you'll see here is as soon as I save this, I have like this new test over here on the testing pane. And I guess initially it's just going to load everything up. And it's asynchronous. When I start my thing, it's actually not doing anything, right? Like it's what I want to do is actually want to wait until the workflow finishes. And so I have like this utility here that calls wait until, and it takes a predicate as well. And here I'm going to need to basically do joke, make jokes pod status equals status done.
right. So while you're doing this, I'm going to answer a question real quick. Then we got to sign off, buddy. Sorry, because we have other shows coming on. But the question is, does Winglang work in GovCloud? Yeah, if you use CloudFormation, GovCloud, if you use Terraform, at the end of the day, it's just IAC and code. So yes, it will work in GovCloud.
It does.
So, all righty. And are you running your test?
I'm running my test. I don't know if it will work. I think we won't have time to see it, but
okay. All right. Yeah, with that, I do have to sign us off. Elad, as always, it's incredibly enlightening to learn from you. I don't know if you saw the joke, said Elad has the endurance, but I just pray the keyboard hangs in there. That was funny. But with that, we're going to sign off. We're here every Tuesday. Join us, and we'll see you later. And I'm going to sign us off now because I want to make sure the other group gets time to start. So thanks, all. We'll see you later.